All right, so doing number 21 and 9.3, they basically ask for a triple angle formula for cosine, right? So that means I want to come up with cosine of 3t is something, okay? You have two options for this, maybe two easy options at least for this. Yeah, so you could use Euler's to make de Moivre, and then you could use de Moivre to run through this. Yeah, that'd totally work. What else could you do?
Cosine of 2t plus t.
Oh, good. So you could think about 3t, right, as t plus 2t, and then run the sum of angles identity once and the double angle identity once. What do you guys want to do after? Show of hands for de Moivre's. Show of hands for the other thing.
The other thing?
Okay, cool. Sounds like the de Moivre's have it.
Yeah.
All right, so let's try de Moivre's. Feeling your book back? Okay, so to get de Moivre's, I think I better look at what? What do I want to look at? I want to look for cosine of 3t in there someplace, right? Okay. So I need e to the I 3 theta, right? Which is on the one hand, right, out of Euler's. This is cosine 3, oh, I guess I did thetas. I should do t. Cosine 3t plus what? I sine of 3t, good. So that's, right, this is straight up Euler's with 3t as the angle. On the other hand, e to the it is e to the it, or e to the I 3t is e to the it cubed. So this should also be cosine of t plus I sine t, right? That's Euler's again, but then cubed. So de Moivre's is this top thing, like with cosines, has to be the bottom thing after you FOIL it out. You guys with me on that? Mm-hmm. Okay, so I had best get to foiling this thing. You guys want to know a quick trick for foiling? Like, I'm going to have to multiply this out, and then I'm going to multiply it out again, right? There's a trick for that, which is this thing called Pascal's triangle. Have I shown this to you guys before?
You have not.
Okay.
Used to be.
So
I've seen it.
you make a triangle out of numbers by starting with 1, and then the next row is 1, 1, and then the next row is 1, 1 with a 2 in the middle. Where did I get the 2?
You add the 2.
Good, you add the 2 numbers above it. So here my next row is going to have 1s on the ends,
1s, 3s.
and then it's going to have a 3, and then a 3. So I'm adding these 2 numbers to get that next one. So my next row is going to be what? 1, 4, 6, 4.
You got a bumblebee on you.
Yikes. Being attacked. This is what I get for living in beautiful sunny California. Okay.
Okay. Oh, yeah.
Good. Which row did I need?
It's going back.
Coming back. Go away. I'm not a flower. Super glad I don't have pink on today. So I need the row with 3s. Oi, go away.
I'm gonna finish this outside.
Yeah, take your orange peel outside. All right, so I have 1, 3, 3, 1. So what I need to do is I need to FOIL this sucker out. So the way I do that is I go, okay, so the first thing, right, is going to be the firsts of all those things together. So that's going to be a 1 cosine cubed of t. And then at each step here, I'm going to add, I'm going to put the number, and then I'm going to trade one of the first thing for one of the last thing. So right now I have 3 cosines. So in my next step, I'm going to have 2 cosines and 1 I sine. You guys with me on that? So my next step is going to be cosine squared t times I times sine t. And then my next one, I'm going to have a 3 and a cosine t times what else? Okay, times I sine t all squared. And then in the last one, I'm going to have plus 1. And what's that thing going to be? I sine t all cubed.
I didn't know that's what it was used for.
Yeah, this is basically what Pascal's is good for.
Because you learn that really early, but then it
Yeah, it's kind of a fun, like, it's a
little puzzle.
It's a trick that teachers use to occupy students that are kind of a pain in the ass for a little while. So,
Got it.
right, this is the thing you use to occupy the smarter students when you have, like, kind of mediocre students in 3rd grade. You go, okay, here's Pascal's triangle. Fill this out to 10 rows, and then you buy a bunch of time to go help the other kids.
I hear that has some extremely awesome implications.
This thing?
Yeah.
Yeah, this is a cool trick. There's a number of other cool things you can do with this. There's some choose notation stuff that can be sorted out of this thing. So yeah, this is a cool trick. Here, I think I just need to collect what? I wanted the cosine 3t pieces, right? So I just need the ones that don't have any i's in them. So this thing doesn't have any i's in it right now.
Because we're multiplying the I.
Yeah, so this guy's going to have an I stuck in it, right? So this one's going to go with the sine triple angle identity, which I don't need right now. So I'm just going to ignore that one. And I'm just going to suppress that. And then this guy, does that have an I in it?
Yeah.
Yeah, it
no,
certainly seems to.
But it'd be negative.
But you're going to square it, right? So you're going to get an I squared, which is -1. So I can drop the I out of here and just flip this sign. And then this is one of the things that's all real. How about this guy? What do you get when you cube I?
Negative I.
You get -I, so that one also has i's in it, right? So the cosine triple angle identity, so cosine of 3t, right, is just cosine cubed t minus 3 cosine t sine squared t.
Woohoo.
Cool? And as a bonus, we got the sine one. So what's sine of 3t since we're here? Yeah, it'd be all the stuff with i's in it. So looks like I got 3 cosine squared t sine t. And then how about minus sine t cubed? Where'd the I go? I'm just kind of using it as a marker, right? This guy's an I sine of 3t. So this guy's got an I in it. That means the rest of it goes with the sine of 3t. And this guy's got a negative I in it. So the I is just a marker and the rest goes in here. Just cool with that? If you want to see that separate note, it's like this. It's I sine 3t is 3i cosine squared t sine t, oops, minus I sine t cubed, right? And then you just take this whole equation and divide by I. That's cool. Questions, concerns, deals? Bees. Bees are a concern.